Okay, so today, my name is Aidyn, and first of all, thanks to the organizers of this event and organizers of this challenge. So today I'm gonna show my solution for the grant challenge, COVID-19 detection grant challenge, and I'm gonna show an approach called Ensemble learning to COVID-19 detection. So I'll start talking about the solution and then talk a little bit about an approach that could be used to improve these types of chest X-ray classification problems given opacity regions. Okay, so the task was to classify the images into either being COVID-19, normal, or pneumonia. So the metrics were accuracy, sensitivity, and specificity in decreasing order of importance. So we had 18,000 chest X-ray images for the training set, and we had a public validation set which had about 3,500 chest X-ray images. I took the training set and firstly divided it into 5 folds using stratified k-fold, stratified by number of classes. By the classes, and also I took this public validation set and used it to check how my models are generalizing. And the testing set had about 1,200 CXR images. So the distribution of classes for the training set could be seen down below. So there were about 6,500 COVID-19 images and 4,000 pneumonia images and about 7,000 normal images. Okay, so firstly, I used heavy augmentations to expand the data set. I used online augmentations implemented in Augmentations library. So these are like some geometrical ones, such as horizontal flip, random crop, shift scale rotate, and I applied shift scale rotate for 90% of the images, so that the models are rotation invariant. And other augmentations for changing the contrast, brightness, gamma values, and so on. Also some blurring effects. Okay, so here are some training details. So for the loss function, I used weighted cross entropy with 1.5 with weights of 1.5 for COVID-19 and pneumonia, and 1 for the healthy class. So during training, I noticed that for the validation set, my models were doing very well on the healthy images, but not so well on the on discriminating between COVID-19 and pneumonia. So that's why I decided to punish the models more for incorrectly classifying these classes. So I used Atom Optimizer and with this initial learning rate, and I reduced the learning rate whenever the model plateaued for 4 epochs. Okay, I trained about 30 to 60 epochs with batch size of 32 to 160. So I tried to put as many images as possible into my GPU. And for diversity, I use different image sizes. So 224, 384, and 512. Okay, the hardware I used was Tesla V100 with 32 gigabytes of memory. Okay, so the larger models I trained with smaller image sizes, and the smaller ones with larger image size. It also helps the ensemble learning since if there are some opacities that are small, probably the larger image sizes will capture them better. Okay, so for the models, I used ImageNet pre-trained models. Those are EfficientNet V5, new EfficientNet version 2 M, Ceres Next, Swing transformers. So I tried to pick the models from different families so that the ensemble learning has some heterogeneity and diversity, because learning the same features would not be beneficial. So to ensemble the models, I simply used averaging of the output probabilities. And So yeah, during the inference, I also used a horizontal flip test time augmentation, again by averaging the output probabilities. Okay, so the individual models were giving about 94 to 95% of accuracy. So I didn't track every single model, but yeah, some of them were giving the accuracy in that range. And the final result was 96.5% of accuracy. Okay, so it's worth to note that usually in these types of so it's worth to note that usually in chest X-rays, the opacity regions could be discriminating features. So as you can see in this image, for example, if we have an opacity region that is shown with this red bounding box, usually the model tends to focus in these opacities to discriminate the classes. So in this challenge, obviously, we weren't given these labels, but I would like to briefly talk about an approach that could improve these types of chest X-ray problems where we have opacification regions available. Okay, so let's imagine that we have an image that has opacity regions. It could be anything like bounding box or maybe segmentations of these opacities, maybe circles or anything like that. It first goes to the augmentation, and from this augmented image, we can derive the binary masks that, as you can see here, we just color the inside of the opacity regions with ones and the outsides with zeros. So the augmented image goes to the model. So the model can be divided into several equal CNN blocks. And after last couple of blocks, we can add segmentation heads that segment the opacity regions from the feature map. This ground truth can be resized, and binary cross entropy loss can be calculated and added up to the final loss. The hope is that this models start focusing more on the opacity regions because these are the discriminating features. Okay, so I evaluated this this approach in CIM COVID-19 detection challenge in Kaggle, and it received a gold medal solution. So as you can see, this is some experiments with like 5-fold averages. So that's why it could be stable and reliable. With auxiliary heads, the model had much higher mean average precision. We can examine further, to see why this happened. So firstly, this is just these are GradCam visualizations. So where the model focuses on to make predictions. As you can see, the model usually tries to focus on these opacity regions. So opacity regions are given with red bounding boxes, as you can see here. Okay, so firstly, each cell shows two images, two heat maps. So the first one is for the model trained without auxiliary branch, and the second one trained with auxiliary branch. So as you can see, the model trained with auxiliary branch is much better at capturing these opacity locations, and that's why it classifies much better, as can be seen from the results I've shown before. So yeah, so this is how we can force the models to look into these opacification regions and discriminate better. Okay, so that is it. Thank you for your attention.